So no changes, and about today's schedule. Before 10 a.m. we have 40 minutes, and I'm going to talk about data processing, preparation, and some topics related to that. At 10 a.m. Hiroshi Shibata will join our meeting. Also, school invites some other students from previous course, from previous stream. So some people will join our meeting during Hiroshi speech, and then we continue on a regular schedule with computer vision topics. Okay. So about data. First of all, we need to understand what we can do with data, how we prepare data to make it ready for further analysis. Also, we need to understand how we can organize and go through the data annotation process. Usually, we need some annotated data from external annotators, or we can do this, like if you want to develop something from the scratch to experiment, you can find some software that allows you to perform data annotation in simplified form. Yeah, and also preparation data for evaluation and validation. Okay. Regarding pre-processing, let's say we are developing neural network that technically is able to learn how to classify different types of objects, let's say cats and dogs or something else. And one important thing about that we have in our architectures primarily, we have a thing that is called input layer. As you might remember, we usually use fully connected or convolutional layer as an input layer. And the problem with this is that usually to perform even one forward feed operation through neural network, we need also specify the size of input X vector. All the layers consist of predefined number of neurons and predefined number of inputs for each neuron. It means that this X vector should be almost for all architectures of predefined size. So we just should make a decision of which size of input data we are going to use. But this size also is a function of initial size of image, right? As you can remember, our image is a pixel map, maybe 1 or 3 channels. And what we do with this image is to like just taking all the rows and flatten them just in one long line vector. And the size of this vector would be like n by m by 3. So it means that if we want to have the size of x vector the same, to be the same all the time, we need to have images of the same size initially. But reality is not like that, because usually what we get from the internet, whether we download images from one resource, or maybe perform web scraping, or taking photos from somewhere, usually we get images of different resolution. And also it is even better to obtain images from different sources, because if we take images with just one type of camera, it also means that our input is like a little bit overfitted to this type of sensor, this type of camera. But regularly, usually we need to be able to process data from different sources. We want to be able to recognize cats on photos taken by phone, professional camera, or maybe even a screenshot from the web. So different, slightly different conditions of getting photos. So generally, we have images of different pixel size, and also maybe different color depth, like a little bit heterogeneous input. And in order to do this, to keep X of the same size, we need to run all the images we have as an input initially, before even training, evaluation, and anything. And then before any inference operation, as you can remember, inference is prediction time. Inference is what happening in production. When we already deployed our model, our solution as a software, we use this model internally for predictions. This prediction is also called like inference. It's an inference operation. It's like terminology for machine learning. And for inference, we also need to take any image, pre-process this image, prepare its format to be ready to be fed to neural network. So for that, we need to do things like resize image. It can be done by using like different types of tools, starting from regular things like image pillow library for Python. Yes, weird name for image processing tool, but it is like that. Also, we can use any software like GIMP, Photoshop, or something. I primarily use Linux system, so I don't use Photoshop in general, but Photoshop is nice option. I don't mean that we use this software like with graphical user interface. Instead, most of professional software supports batch processing for images, so we can prepare, predefine some procedure how we convert what we do with just one picture, and then prepare big bunch of images and run this procedure automatically without running user interface. There is such a possibility for Photoshop, for GIMP, and for many other software. Also, there is a very good set, I'd say state-of-the-art set of image editing and manipulating utilities called Image Magic. It is available on Windows, Mac, and Linux platforms. And there are several forks of this software. And the difference is how the word magic is spelled. Like there is image magic, magic CK, and image magic. All the options are available, and and the difference is just different forks with primarily different type of licensing. It is also possible that some difference can appear instead, but generally they have the same API, the same names of utilities, but a little bit different spelling and licensing things. Yes. Also, maybe not resize only, but maybe we need to normalize like color depth. For example, if we have not 1 byte encoding for 1 pixel, it could be 1 byte encoding for 1 pixel for one channel. It could be integer and much longer than regular integer. So it depends. And for neural network to be able to handle this, we need to have like normalized encoding there. So this is one thing. In addition to that, we also need to think of situation. If, let's say, we need the image like of this resolution, for example, but instead we have image of this resolution. It seems that it is possible like to reduce the size a little bit, right? So that we get this type of image. But what we are going to do with left space could be unclear. And the answer is the word padding. Padding. So we pick some common value for pixels that we are not going to consider to be informative. We could, for example, fill all the pixels with zeros or with 2 5s instead. It is very rare case in real life that from sensor we get zeros or 255 values, because it is absolute light or absolute dark. It's not real situation, it's very rare situation. So generally we can use these values for filling not informative part of the image. So this is another step. Also, it is possible that we probably will need to apply some filters. For example, let's say we get images from many sources, and these sources, they have different white balance points. So we also probably, in some cases, may need to rebalance white, maybe add or remove saturation, and many other operations. So pre-processing means exactly this. Sometimes also pre-processing already includes converting images into binary representation that isn't renderable anymore, just like substitute each image file with NumPy vector. You should remember what is NumPy. NumPy is a Python library that allows us to manipulate with vector, matrix, and tensor data easily. It supports linear algebra operations on arrays. But also it supports storing data on hard drive using serialization and deserialization technique. So if we have something, let's say big vector stored in our memory, we need to be able to save this data on hard drive or send this data over the internet and then load back into memory when we need. Both operations have like official name in software engineers, like serialization and deserialization. Serialization means that we computed something in random access memory and then put this something into storable, savable format somewhere on disk. This is serialization, and the deserialization is a post operation. So we get some file and load it back into memory, preserving format and data type that this language understands. Usually it is language dependent, but also could be language independent. And NumPy supports different Python dependent and Python independent formats. So when we save images or any other input data, or even if we want to save our binary representation of our model into some format, we can use files like MBAI means NumPy serialized format, and also there is such a format called H5. This H5 format can be loaded back in any available language, not only Python. And this is why these types of serialization is used very often, because we can reuse this model in some other language and other frameworks, not dependent on Python. Yeah. So we can use this NumPy library to convert image files into vectors, save each vector separately or all together in one or many H5 files, store those files on hard drive, and then in future we can reload this data for training, or maybe if it is already waits for a model, we can load the model back and use it in our runtime. Saving the model in this format is a very convenient thing, because we can pre-train neural network, save weights, and then in production, when we restart service or restart server completely, or deploy our system somewhere, we can deliver source code that is going to be launched, and also deliver the model itself represented in H5 format, and roll this set of weights out to memory, so that we get this model work immediately without any need to run training process again. It is especially important for the models that cannot be trained quickly. So, for example, Google can train some model for months, but training result can be stored in, let's say, H5 format, and then will be used by other people and companies quickly. Yes, and in this way, our data set, we know that our data set consists of images, but you get this data set already in some format that is readable just by programming tools. You cannot see these images easily. It is still possible to load this data back into any program, take one X item, reshape it using standard image manipulating tools, for example, Pillow library, and draw it inside, let's say, Jupyter Notebook, and even save it back to JPEG or PNG file. But the reason why this processing can be done before running training processes is that all the data manipulation operations also imply some computational resources. And if we have a big data set, like 10 million images, and if we pre-converted all these images into vectors already, it saves our computational time and also power. Maybe we can save some memory for that. If we retrain the model many times, if we running experiment on top of this data, so we need to train the model, let's say, 1,000 times with different set of parameters. We won't need to convert all the images into vectors all the time. Just one time, save in H5, and then reuse this million times, or even more. So this is about preparation of format for images. For video, it is almost the same. Everyone understands that we consider video to be the set of frames that are put in line. Usually video represented as a set of frames, but they are not homogeneous frames. Each file format, each stream format for video nowadays consists of at least 2 types of frames. Keyframes that are in fact can be something like JPEG file or PNG format. It's something very close to that. But all other frames, they are much smaller, and they contain just some instructions how we should modify keyframe in order to get new version of frame. This is how different codecs and compression, video compression algorithms work. Then at a certain point we reach new keyframe, and from this point we forget everything that was before and continue updates with non-keyframes further. And for this situation, it depends on what we want to do with our data. But if we need to process all the frames in the same way, what we need is to get each frame. For keyframes, they are already rendered, but for non-keyframes, we render these keyframes into images, store them somewhere, and work with them as like with regular images. This also means that the size of data set is much bigger than initial video, because we store all the frames as keyframes, right? So we should provide much more memory at least. But memory isn't the most expensive thing today. Maybe computational power and power itself, they kind of more expensive resource, and it is important sometimes to take video file, pre-process it into set of images, then perform all these operations on top of these images, and this way we can go further with this data. Of course, video processing things are much more demanding in matter of memory and computational resources, but it's like by default video, it's always much larger than just one shot. One important thing about video, it is very rare case when we have really high resolution video, because for images it is common to have very big photos, to have nice resolution there, but for video we still consider full HD image to be quite large. Full HD is like this resolution, but for photos it can be much larger. So sometimes video could be not as big as each frame from the video could be not as big as a regular photo. So this is about pre-processing. This pre-processing can be done almost manually. You can automate this using these tools, but also when you deal with any framework like Keras, TensorFlow, PyTorch, modern frameworks, they also contain some special tools for data pre-processing, and it means that most of this operation, if you use Keras, you probably can do all the set of operations, or like 90% of operations using functionality provided by Keras. But still, you should understand. The first thing is pre-processing. Then, even in this example, you had a chance to look at, you notice that we split data into three groups, like training, testing, and evaluation. I think you understand why we do this, but this is so common operation that Keras, TensorFlow, and other instruments still provide many APIs for splitting data into these portions. But about that, we will talk a little bit in more details during evaluation, because we also are going to talk about cross-validation thing. Have you ever heard about cross-validation?
Yes. Yes.
Alexander Romanko told you, right?
And statistics course also included this topic.
Data annotation. This training set we have for cats and dogs was prepared by someone. People took many photos of animals and put labels, what is what, where we have a dog, where we have a cat. And this is one type of labeling, but it's applicable only for classification. For situation where we need to train object detection thing that is able to find a cat. Sorry for my horse-like cat. So object detection or even segmentation, we need to have training examples of this format. And for that, we of course can use things like Photoshop or something, but everyone should understand that Photoshop isn't a tool for data annotating. We can find some curve there, we can save some layers in Photoshop, we can programmatically access this information in Photoshop files and then prepare some data sets by converting Photoshop format. But it is inconvenient and there is no common procedure for that. Instead of that, data science community already came up with several different formats and default tool set that can be used for data annotating and storing the annotations. And let me show you one example how data annotation can be done. Actually, we have only 10 minutes to go, so I think that before Hiroshi join us, I'll be able to show you just this thing. So, do you see my screen?
Yep.
So, actually, you see a special tool. It is just one of one option. There are many. This is the one we used for our project about building annotations and houses recognition I mentioned yesterday. And this is how that annotation process is organized for this project. It is important to take a look at this. So in order to run data annotation process, we need to take some data that are not annotated. And for that, we could use even something like Google Earth. You should remember this software. Nobody uses it anymore because we have Google Maps in the web browser, but let's take something someplace in Canada. Personally, I really like Ottawa. So we see some buildings here. There is a possibility to save. Sorry. To save this. Somewhere, let's say, just pictures. I'm closing this Google Earth thing. Let's go to pictures. And we see, oh, okay, this is what we saved here. So we have just an image. We can get it with different scales. For example, this one is also obtained from Google Earth. So the first step is to find some resource, whether it is software or already prepared collection of images or videos without annotation, pack them into some archive. For example, here I have 5 photos and packed them into a zip file. And then we can create a thing called task, or we also call it job. Upload here and get the item like this. We can log in into any item. Oh, sorry. And perform annotation operations here. Let me show you how annotation looks like. It's been loaded for some reason for a long time. I'm not sure. I haven't launched it for months, so maybe it isn't. Oh, it works. Yeah. Sorry, I've already clicked back button.
Is this your own service developed, or it's some common service?
This CVAT software, it is open source solution. I just want to recommend it for you for situations when you need to do something with data annotation. If you need to organize the process, you can use this data annotation tool, CVAT. It is available on GitHub for free. It is like license MIT. You can use it for your needs, and you can even modify it and reuse. You cannot embed this solution inside commercial product, but if you just use it, it is possible to do it for business for free. Yes, and you can perform many types of data annotations here. Let me show you, like I want to show exactly this link to you. It takes time to load entire annotation, but I want you to see this, how it looks like, because it is quite interesting thing to see. So each building has a roof, and this roof has several sections, several parts, and we use different polygons to annotate data here. And finally, we can save this annotation in one of the most common format. For example, when I have already annotated things, I can dump annotation in one of the fixed formats. The etymology of these formats, it is quite simple. Some companies, some research groups came up with convenient formats for them. They shared these formats, and some formats became very popular. So here you can see several formats, and they are really common. So we primarily use this Coco.json, but also others are nice too. So we take Coco.json and save this in some JSON format, and then let's go to pictures, save it, and let's see how it looks like. It means curiosity to join. JSON is textual-based format, something like this, and it says what and where is annotated, like textual description of annotation. We actually saved not this file, but or okay, maybe this file, whatever. So when you have this initial raw data and annotations saved in some of common formats, you can easily use, for example, Keras framework to load this data into memory of your program and run their training of segmentation, object detection, and whatever we need. Like if you take a look at main page of this CVAT, you also can see how this annotation can be done for different types of format. This is segmentation annotation for picture. It also supports annotation for video. You can get video file, annotate one frame, and then continue annotation for all upcoming frames. Usually in video, we have just slight changes to the next frame. So if we make a step to next frame, we can change things a little bit and get new annotated frame. But also annotation supports kind of animation. And tools like this, they usually support it. Actually, let's try Google search for that. So it could be like, is it video or not? Just a moment. So this is an annotation for object detection. They put bounding boxes where it is needed. But also they can do things with segmentation and interpolation for video. Let me try to find interpolation mode. Interesting. So here, they put bounding box here and then move this bounding box for each frame so that they get many pictures annotated just by using this thing. It also can be automatically detected. So this bounding box can be proposed for next frame, even in this CVAT software. there are also many other things that can do better maybe, but Civada is open source, so you can use it. So one important thing about Civada, you can roll out, deploy it on some server in cloud or in your local network, and many people can work in parallel with it. And they don't need to install anything, they just run this in web browser. That's important. You just should know this URL, and you get all the jobs available. So any annotator can log in with personal credentials and perform annotations so that you get work done in parallel and you know who did what. And it's important for process organization. Actually, I think it's time for Hiroshi to join. Let me check about this.
He's here already.
Oh, I didn't see. Hiroshi, do you hear me?
Yeah, I can hear you. Yeah,
Oh,
can you guys hear me well?
Yeah.
Yes.
Unfortunately, I don't see your face. I don't understand this. Oh, I see now. Yeah.
You see me? All right.
Yeah. So
Can you switch off share screen?
yeah, you can do this. I'm stop sharing and let me introduce Hiroshi to you guys. Hiroshi is my business partner and kind of famous person in Japan because of blogging about technical and AI ML things in Japan. And for now, he's also famous person in Ukraine because Hiroshi, I'd say for many businesses, he's an entry point to Japan business. So he's familiar with artificial intelligence things and business things and can connect together both in different countries. For now, it helps me to communicate with Japanese business. So yeah.
Yeah, thanks for your introduction, and then also like thank you very much for inviting me to this seminar. And for those of you that never heard of myself, I'll just quickly introduce myself, and then I have prepared this little presentation, and I'm going to share a screen and hope you can see this. Just a minute. Can you guys see my screen?
Yes.
Yep.
All right, so I actually prepared for this presentation slides for IT Duni Pro conference. So basically, I'm a IT consultant here based in Ukraine. Right now, I'm in Kiev, not so far from KSE actually. It's like a 5 minutes walk, and it's unfortunate that this coronavirus pandemic is ongoing and everyone has to stay home. I hope everyone staying home and keeping yourself safe and healthy. Hopefully after this quarantine time, I can visit KSE and meet you guys in person. So I'm going to talk about AI and what kind of demand they have in Japan. And before that, I'm going to have to introduce myself. You might be wondering who I am. So my name is Hiroshi Shibata, and I was born in Japan, but I spent many years abroad in the US, UK, and Australia. I have almost 10 years experience working in investment banking as a IT consultant and bridge project manager. I have several businesses on my own, internet-based. I've been in Europe since 2016. Specifically in Ukraine, I've been here since 2018 December. So I've been here for almost a year and a half. I have many titles. So as you can see, like I have my own IT consulting service. It's called Agora IT Consultant. I'm also a Japan representative of IT Ukraine Association. And I have a couple of my own internet startups. And I'm helping several Ukrainian businesses, including an IT company, Ukrainian IT company called Mobilunity. And it's such a coincidence, but this Mobilunity is in the same building as KSE. So, but different entrances. So, it's in the same building. So it's basically it's an IT company, and they have like about 300 people. I'm basically a Japan country manager, and help them to promote the business in the Japanese market. So and also like I'm helping CHI software based in Kharkiv, and I'm a local Ukrainian director, Ukrainian branch manager of a company Neolab. It's registered under the name of Eliza Software, where Alexander is a CTO, and then I'm basically doing the business side of things. And my responsibility is to connect Ukraine and Japan in the sphere of IT. So this is basically a Japanese company who want to build a remote team. Many Japanese companies think that there's a potential here in Ukraine, and they want to hire IT engineers here in Ukraine. There's a shortage of IT resource available in Japan, and they're desperate to hire people outside of Japan. Well, why Ukraine? I'm gonna explain that later. But Ukraine has a lot of talented IT engineers, and I'm basically promoting Ukraine. I only highlight the positive side of Ukraine, and there are too many negativities coming out of Ukraine. Every time you see Ukraine on media, it's almost always negative. But I'm promoting this. I'm selling Ukraine as a tech nation. And currently, I'm the only one who's doing it. So I should be actually awarded by your government, but I'm doing this for for Ukraine. And I also have a blog on IT media. It's one of the largest IT tech media in Japan, and it's I'm writing a blog about Ukraine as a tech nation. So if you're interested, you can take a look, but unfortunately it's all in Japanese, so you're gonna have to Google Translate and read it. Like I said, my mission is to connect Japan and Ukraine. So this was taken last year with the ambassador of Japan, together with the chairman of IT Ukraine Association. So basically, I invited Japanese IT Association to Ukraine, and has signed a memorandum of understanding (MOU). So they began last year this cooperation, like partnership between Ukraine and Japan, and this was a kind of epoch-making moment that these two nations cooperation had began. Basically, it didn't exist before, but it all started last year. after I started this whole thing. So like this is with your I think former deputy prime minister Mikhail Fedorov, and I think he's still a minister of digital transformation, and he's trying to make Ukraine into like more like highly digitized nation like Estonia, and I know that he's leading this initiative, being in having an IT background himself. I think he, and being so young, I think he has a ability to achieve that. And then I was invited to the presentation. I also invited a lot of other Japanese companies to this, and that was also very epoch-making moment, and that took place last year. Also, like I have brought a lot of Japanese companies to various universities in Ukraine, and this photo that you can see is the from Kharkiv Polytechnic Institute, and this old gentleman is the principal, I think, and we were very warmly welcomed, and they're very keen on working with Japanese companies. So working as in Japanese companies want to hire talented new grads from Ukrainian universities, including KSE. So so that means like they have. I am expecting more Japanese companies coming to Ukraine and set up the remote team, or if any Ukrainian engineers wish to relocate themselves to Japan, and then I will also help them with that. But yeah, so this is kind of cooperation I'm thinking. For those of you who know very little about Japan, I will have to explain what basically like briefly what Japan is, and because it's being so far, I think average Ukrainians have little knowledge about Japan. Alexander has already been to Japan for business trip, but I think most of you guys have never been to Japan, so I'll explain a little bit about Japan. So it's the third largest economy in the world, so after USA and China. Until 2010, I think we were the second, until the China took over, unfortunately. But now we're the third, and the fourth is, I believe, Germany. And 11th largest population in the world. So 120 million. That is roughly 2.5 times larger than Ukraine's population, I believe, or maybe three times more, something like this. And Japan has provided a huge monetary assistance. There is $3.1 billion May 2017, which most people don't know. But anyway, and this is Japan is basically becoming more touristy. Unfortunately, this year's Tokyo Olympic has been canceled, and this was something that no one expected before. But until 2018, we have like 2018, 31 million foreign visitors visited Japan. Last year, I think 40 million. And this is important. And 2% of Japanese population is non-Japanese. So like Japan is becoming more and more multicultural. So traditionally we were very monocultural, but we're opening our doors to non-Japanese. So this will contribute to the decreasing Japanese population. And yeah, and like I said, in terms of GDP, Japan, as you can see, is the third, after US and China, and then another country followed. I created this slide because right now it's a hard time for everyone, and that affects our lives and our businesses. Traditionally, I know that a lot of Ukrainian IT companies, their main focus is Europe. First Europe, and then North America, like USA, Canada, and probably 90% of business, they focus on those markets. And then probably a little bit of Israel and other areas. But what happened was, Europe and North America has been hit really hard by coronavirus pandemic. So like now, a lot of IT companies are losing their businesses, and they don't have new projects. They are restructuring their teams, and people losing jobs. And this is kind of risk of focusing on just one or two markets. And fortunately, Japan still has not yet experienced hard lockdown. So that means like business is still moving as usual. So our project, for example, the project that I and Alexander are doing, still ongoing, and nothing has been shut down. This is kind of a benefit that you kind of diversify the risk by acquiring a new market, such as Japan. Japan is too big to ignore as a market, and I think this kind of whole situation right now has proven that Japan is a market that you guys should focus on. And there are a lot of big Japanese companies. If you look at South Korea, for example, there are Samsung, Hyundai, LG. So like those takes up like probably 60 or 70% of the GDP. So if one company collapses, and then the whole economy collapses. If you look at Japan, we have a lot of large corporations, and it's not like a few companies monopolizing the industry. So as you can see, like Toyota is quite huge. However, we have other car manufacturers like Mitsubishi or Nissan, Suzuki, Honda. We have a lot of other car manufacturers. So like Japan has I think that the advantage of Japanese market is that it consists of many different businesses, and the market itself is big as well. So it has a huge potential if you start looking into this market. And the SoftBank is not a bank; it's an IT company. It's the largest IT conglomerate, and they basically it's like a Japanese Google. And then I'll explain that a little later. But basically, SoftBank has a huge. I think the right now, because of the recession, I think the market cap has decreased slightly, but it's still the largest Japanese IT company. The SoftBank is. And the Rakuten, as some of you may have heard of, I'll also explain what Rakuten is shortly. So this guy is a CEO of Rakuten, Mikitani. So basically, it's a Japanese Amazon, and basically Rakuten has acquired Viber. Viber is I'm sure that most of you guys use Viber every day, but basically back in 2014, Rakuten acquired Viber, and as a result, they have created a huge R&D center in Ukraine, and they have made a significant amount of investment here in Ukraine, and I also met their top management 2 months ago, and they were here in Kiev, and they were going to open, their R&D center in Kiev. And I think initially, I think they're going to start from a creative state. I think that because they only have like 30 people right now, but then eventually they're going to have like a few hundred people. So this is like a long-term plan and long-term commitment that they are going to have with Ukraine. And but this is, when last year when Mikitani met your president, and it was a surprise visit. And like I said, they're committed to create a R&D center here in Kiev. So this is my team, Neolab Ukraine, and you can see Alexander here, and me, like myself here. With Neolab Ukraine is where I'm doing the branch manager. It's a first Japanese IT company here in Ukraine, and we have launched our first physical office back in October last year. Our office is close to the KPI, and we currently hire 25 staff. The youngest is 23-year-old. I think she's the youngest. And our current IT AI project, basically, I think Alexander has explained the project number 3 just now. But basically, like, our main focus right now is the computer vision. It's a smart restaurant, a smart supermarket using face recognition technologies and behavioral detection. So people tracking, in other words. And this system is also planning to be used for places like stations, like railway stations, and in other places. So it's more like a smart city. And then, number 3, like computer vision, about this drone. We fly the drone, and the drone takes some photos, and we analyze those photos to detect the roofs and vectorize them. And number 4 is the reproducing 3D model of our mouth, like inner mouth, and AI can detect, where's the gum, and where's the teeth. So those are like can be done, like can be automated. So these are the projects that we are currently doing, and we're not stopping because of the coronavirus. We have business as usual, and still ongoing. Everyone's working from home. This is the first project. We call it store stats, and so basically what it does is people walk around the shop, and we make a segmentation on the floor. So like let's say this is floor A and floor B and floor C, and the system can automatically detect how many people are present in each segment, and then how basically this dashboard on the left you can kind of filter out the time, and like this system is supposed to detect face and gender and age as well. So it can be used for marketing purposes. So this is like a gender age detection. As you probably all know, that this can be achievable with using cutting edge technology. Basically, we're using state of art technology available in the market. There are some bugs, you can see. I think red is supposed to be female and blue is male, but obviously this is not male. So like there are some bugs. I think we still kind of trying to fix the bug and improve the accuracy. That's what we are currently doing. And so basically going back to the argument of decreasing population in Japan. So why is it important? Because AI might be the solution to this issue. Like we have a decrease in population, and young people don't want to do crappy jobs. So who wants to do it? Either we accept immigrants and let them do it, or we create robots or automate the process by using AI. So basically, other countries has already gone through this. UK, Europe, USA. Like you can see, like we have a significant number of older generation, and 34.6 million people are aged 65 or older, and that is a really high proportion in the population, and that is the AI. How could AI solve this issue? Let's see what our Prime Minister said. Basically, there's a government initiative that he announced. I think it was last year. So our Prime Minister Shinzo Abe, he's been Prime Minister for the past 6 years. Anyway, so what he said, like he set the initiative called Society 5.0, and that is, to the government promote the use of AI in every sphere of business. So people might think Japan is a highly digitized, technologically advanced nation, but actually, from my point of view, Japan has a lot of analog technologies, and that they have not yet achieved the digital transformation. And that means that there's still room to improve. There's still a chance to sell, our capacity to help their business in, more digitized, more automated, and also now at school they start teaching informatics starting from 2022, and the area that we have the biggest shortage of resources is AI. So they say, we are in short of 250,000 AI engineers. So how can they find those people? So Ukraine has, as you can, as you guys are, has a lot of talented AI resources, and Japan can use your help to fill their shortage of the labor market in the area of AI. So this is what I'm trying to do right now. So as you can see, I just here, like I'm showing you like 3 countries comparison, how AI is implemented in each country, like USA, Germany, and Japan. So as you can see, well, in terms of AI implementation, the USA is ahead of Germany and Japan. But Germany is catching up rapidly, I heard. Japan's still behind, far behind, and this might surprise some of you, but like I said, Japan is not that highly technological nation like your president said last year. This is the kind of misconception that stereotype that a lot of people have. If you go to Japan, people prefer cash. A lot of restaurants don't take credit card. They say they only accept cash, and like Uber is not. Uber is illegal, I think, in Japan. So like you can't use Uber, and there's a lot of regulations that you cannot that kind of prohibit people from using technology that's common outside of Japan. So
sorry, is this graph like surveys of businesses or something? For AI implementation?
So like this graph shows that the how much like how much AI like technology is used in business. So this is like so like 13.3%. For example, if you look at USA, the business try to use AI to improve the business efficiency. So that's what it means. Like it's from a business perspective. I hope that's answering your question. All right. So I mean, I'm going to explain in more detail. What is so this is like kind of answering your question like a little bit. So this is like a kind of breakdown of AI implementation per industry sector. So as you can see, that this is kind of common sense that the finance and IT, so those two sectors like really fast moving, and they want to always use the latest technology. So they, people can easily guess that why those two areas use AI the most compared to other industry like traditional sector like agriculture, government. They're significantly lower use of AI, because they just don't understand what AI is. Like you have to explain, what it does from scratch. So this is kind of, a lot of work to convince them to use AI, and then how AI can improve productivity and efficiency, and contribute to increase of the revenue. This is a lot of work. But that means there's a huge potential if you get into other sectors like government, agriculture, and then actually NeoLab Japan is actually currently working with some local government, and they understand the importance of AI. So they recently started understanding the importance of AI. So these areas have a huge potential to grow. That's really great news. So people might concern, if AI replace human jobs. Yes and no. So basically, some jobs will be gone, but of course some will remain. But people always adapt, and they change the skill sets and experience, career paths, depending on how the society moves. So this is published by one of the largest think tank consultancy firm like Nomura Research Institute. 601 job types and 49% of the entire workforce will be replaced by AI in Japan in the next 10 to 20 years. I think by and large, it will be the same in other countries. But it says UK 35%, USA 47%. So it's a slightly lower, maybe because their in other countries, already it's happening. So Japan is still kind of catching up, and still some people prefer like a manual processes and manual workflow, and this is why we have like a much bigger room to grow in terms of AI, I think. And so in terms of like a research paper published by each country, so like as you can see, like China, USA, those countries have published most number of research papers in regards to AI. In China, I think they don't need to, as a country, they don't need to care about the privacy issues so much. So it's natural to think that they can just use people's like personal information to improve the models, and so that's the advantage. So in a country like China, could be Russia too, I think it's a very it's like easier. They have easier access to various data sets to improve their models. But we are kind of a little behind in terms of research papers. So this is why we need AI engineers from other countries. So I believe that this is the last slide. So basically, it pretty much sums up what I talked about today. But AI can resolve the issue of decreasing population and also labor shortage, because for some reason Japan is kind of hesitant to accept massive number of immigrants. It's changing, but we have changed the immigration law last year. I think a couple of years ago, they started accepting not only skilled workers as in like IT or finance, but also like manual laborers. So this was a significant change for the Japanese society. Like we started seeing people working on a construction site, like from other countries, and previously we didn't see that, but it's changing. But still, AI can contribute to decreasing labor population, and also like AI can significantly improve the productivity. The human make mistakes, but AI, well, AI can make mistakes too, but basically, it's more consistent compared to the human judgment, and also like can improve the existing products quality and services. It can create other totally like whole new service. And finally, yeah, so like a lot of work can be done manually, but human have to do it, like even if it's boring, but those jobs can be replaced by AI, so that human can focus on something that is more interesting, something more creative, and something that only human can do. So that's all for my presentation. I hope you have learned something. And if you want to contact me, this is my website, email, Facebook, Twitter, and my blog, so you can take a screenshot and take a look. I'm open for any questions that you may have, and please, if you have any questions, just let me know. Anyone?
Actually, guys, I want to ask one question. Hiroshi, actually two questions.
Yes.
The first question is about education.
Yes.
And it is also like kind of two parts. The first part is how to estimate Japanese education about technology and especially artificial intelligence in general for now, and how you could potentially compare the state of AI education in Japan and what happens in Ukraine, and what possibility of maybe collaboration you see in this direction?
Yeah, so I think they, a lot of universities in Japan, they recently like started creating this AI department, but there's still that the technology that they use is not because there's not enough, there aren't enough professors who can teach those really cutting edge areas. Like, I think the biggest problem is that, here in Ukraine or even in the US or other countries, it's really great that, the universities invite people like yourself from like the real industry, like people who actually work in the industry as a lecturer or professor. And in Japan, I don't think it's happening as much. So like what they teach at universities are purely in theory, and it's not quite practical. And as far as I see here, like at least KSE, like what you guys teach is very, very practical. So like what you learn can be used directly in a real situation. So this is a kind of this is something that you don't really often see it in Japan. And then I think it's good that KSE is following the Western style model. Like specifically, I think you guys have a lot of lecturers from I think Canada or North America. I think the model is pretty progressive. I think it's the leading the area of AI. I think this should be the way forward, in my opinion. I think someone who has a real life experience in the AI field should be teaching in university. Otherwise, I think like more traditional universities here, maybe they don't have the capacity to teach AI, but they still a lot of students have a very, very strong mathematical and physics background, and that will greatly help students to learn and like observe and improve their skills in AI, because this is kind of fundamental that you need to know when you start getting into data science. So this is also like something that Japanese universities should consider, but still I think it's still on the way. I would say Ukrainian students or Ukrainian university has higher potential because they have a higher exposure directly to the educational system in North America, for example. And this is really good. And it's good that like for example KSE, I heard that you guys teach everything in English. That's the language that it should be used worldwide. And in Japan, yes, some universities they use English, but still, I think the language barrier is still very high. So I think the language issue is another thing that because it has to be whenever the new papers came out, they had to translate it into Japanese, and it takes time. So there's but whereas maybe if you're educated in English, you can directly read those papers, and you can directly get clients from other countries. So this is a huge advantage for Ukrainian IT industry. I think the fact that they can go global from day one. I think that's a huge advantage.
Thank you. And another question is like you already mentioned language barrier. It is for sure there is also some cultural thing that splits Japan from other economies. And correct me if I'm mistaken, but from like my impression is that generally if we like Ukrainian engineers or AI entrepreneurs could be able to go through this language and cultural barrier to enter Japanese market or Japanese businesses, you told several things that make me think that Japanese market and business quite hungry for this type of technology, AI, computer vision, natural language processing, and other things. And if we can go through this barrier, potentially we can do nice business about AI in Japan, right?
Yeah, that's correct. So like I think a lot of people like concerning like how high the language barrier or culture barrier is. In my opinion, like because initially I thought like it was a big problem, but actually it's a very negligible. It's not significant. It's not a showstopper at all. And the reason is that like more and more Japanese startups, they're actually becoming more English speaking, and also like not only startup, but like a much bigger firms. For example, Rakuten, their official language is English. So even like between Japanese employees, they speak English, and all their materials English. So like the more and more companies, especially IT industry, is they understand the need of hiring talented resources internationally. So they don't stick to just one language or one culture, because they simply cannot hire those engineers that they're looking for, and with the right skill sets and experience, and that they know that they just simply cannot hire those people only in Japan. So they're more flexible, and they're becoming more open to the differences and cultural differences, and also like the language. A lot of companies that I talk to, they have English speakers, and even if they don't speak English fluently, they can type on Slack, or they can communicate pretty well by emails and chat. So this is definitely not a showstopper, and the way they do business is the same as anywhere else. I think they're very punctual, they're very articulate the way they do business, but I think the work culture or business culture is not that different. At least in the IT industry, I think anywhere you go, it's operating in the same manner anywhere you go. So I don't think it's a significant issue, in my opinion. So I think Ukrainian companies or Ukrainians shouldn't be afraid too much to work with Japanese companies, because there's a huge investment, there's a huge demand, there's a huge opportunities from Japan, and I personally think that what Ukraine has, like great talent people, is what Japan doesn't have. And what Japan has, it's a huge investment, a lot of money, and a lot of projects. Is something that Ukraine doesn't have. So this supply and demand is perfect. Perfect. Yeah, I think so.
So this sounds for me like on one hand we have a possibility to like our students maybe from universities who have corresponding education, they can be hired by Japanese companies. But on the other hand, we have many people who understand the nature of entrepreneurship and know something about AI, or maybe a lot about AI, and maybe some of them already have ideas or technologies in their hands. And this potentially can become some kind of business in Japan. So my question is it possible for Ukrainian or Canadian or US-based entrepreneur to enter Japanese market with AI solution or idea to get their market or investment to develop something for Japanese market? And if it is possible and if it is something that should happen sometime, do you have any ideas about like general pattern how we should do that? Maybe some scenario, maybe some resources, conferences, and ways to communicate and get connected.
Yeah, so like I can tell you the perfect example of what you just said, because you know, a friend of mine recently went to Tokyo, like Japan. So like actually, you know, their company is making and a solution like using big data analysis for big banks. And this is actually a startup. Like it's the founders, 3 Ukrainian guys, 2 twins. Well, yeah, like 1 twins, yes. And they are actually invited by Tokyo government together with 10 other startups from all over the world, like not only from Ukraine, but also like from Israel, US, and you know, various other countries. So this is the kind of initiative that Tokyo government said to invite, you know, basically, you know, that initiative is specifically in fintech area, but they actually financed all these, you know, startups from all around the world to come to Tokyo, and they have the you know, pitch and investors, and for investors, and they have you know, like a kind of workshop, you know, with the potential clients, and they actually have acquired some big Japanese companies as clients. Then some of the projects are already ongoing. So and they it's currently, you know, they're all self-funded, but in this initiative there was a program that you know, potentially they seek for investors and, you know, some venture capitals, and so there are various initiatives such as this. So this is just one small example of how Ukrainian startup can get into Japanese market, but also I think there's the most common way to get into Japanese market is that you know, basically if you're a product company, what Ukrainian product company does is, well, what they register the business in California, Silicon Valley, and they actually provide the service worldwide. And then once they, you know, become successful, they take as, you know, Asia or Japan as a, you know, like one of the major markets. And then they create a dedicated marketing team for Japan, and they get into Japan. And I know this one. I know one example, you know, that, you know, who did it. So this company called I think Skyline. I think they have a, you know.
Say it again, please.
Yeah, huge marketing division.
Yeah. So what's the name of company?
I think it's called Skyline. Skyline. SKYLUM. They are in Podil.
Yeah, thank you.
So it's located in Podil. The office, they transformed this unused old factory into the office. It's a huge, few hundred square meters, like huge office. But anyway, what they do is that they provide a solution like Photoshop, and using AI, they can alter photos using AI. They can change the background, for example, and they can change the lighting. They can improve the, erase the blemishes on the face, that kind of thing. So that's like a huge. Actually, it's a big company, and they're pretty big in Japan as well. So because in Japan we have a lot of photographers, art studios. Japan creates most of the cameras. So most of the cameras, the digital cameras that you guys use, from Japan. So we have a huge camera industry and the photographer industry. So this app was a huge hit in Japan. So, but they also sell, market the product internationally. And Japan is one of the I think one of the largest market in terms of revenue. So they hire a lot of people. They even have some Japanese speakers there, and they're very active in Japan. So this is another example of how startup can be successful in Japan.
Okay, thank you very much. Maybe some questions, guys.
Hello, my name is Oleg Moroccan.
Hi, Oleg.
I'm working in outsourcing software company, yeah, and our main client, yeah, from automotive industry, yeah, from the Europe, yeah, and we know that one of the, let's say, biggest competitor of this our customer is Japanese company, yeah, and we know, let's say, and just curious if it's still the case or it's stereotype that Japanese companies, they prefer to order something in Japan only, yeah. So this is a so do you think that it's changing really now, or maybe it's because automotive industry is quite conservative by nature, yeah, and maybe it's let's say just different, yeah, now state of transition. So it's interesting in general your opinion about.
It's definitely changing. Yeah, it's just definitely changing. For example, like there's a Subaru. There's a company called Subaru. I think Subaru, yes. They even have like a big branch here in Ukraine. They actually sponsor AI computer vision conference in Ukraine. So I forgot the name of the conference, but they're investing in Ukraine because they think that Ukraine is great to hire data science for their auto-driven cars, and because they simply don't have the type of engineers they want to hire in Japan. So they see the potential, and that's why they are investing, in a conference like this. So like a computer vision conference. And also, you said like a Japanese car, manufacturers, they're quite conservative. Yeah, but it used to be the case, but it's certainly changing. It's certainly changing. I can see, because in the area of auto-driven car, for example, like the more and more, or you can say connected car, or like kind of, when you crash the car, like you put the sensor that detects, how this accident happened, and that kind of solution is, using AI. So basically, more and more cars are connected to the internet. It's like more like an IoT area, and a lot of Japanese car manufacturers, like they want to invest a huge capital into IoT, but simply no engineers. So they're looking into more like labor markets such as Ukraine, and it's certainly changing. It's Toyota had I think a affiliate partnership with Tesla a few years ago. I think it might have ended, but the more and more Japanese companies are looking into partnership with non-Japanese companies because they have no choice. They simply cannot survive. Being so isolated, not working with other countries, it's not going to work. So they understand the importance. Even the big company like Toyota, or a friend of mine is a Mitsubishi Motors Ukrainian CEO. Well, he's Japanese, but he's in Ukraine, and he actually works with a local Ukrainian IT company because I help them as a consultant, and they understand the importance of working internationally as well. Even a big company like Mitsubishi Motors. So the culture is certainly changing. So I must say, you should not be afraid to get into any industry. You shouldn't have like a kind of stereotypical idea that you shouldn't get into this industry or not. And what you hear from your competitors like German car manufacturer or to me it's like because they're rival, and the information they give you can be completely false. So so basically don't be afraid, but just get into the industry that you want to get into.
Okay, thank you. Thanks a lot.
Thank you very much. Any other questions?
This is Dima Zaskalin speaking.
Oh.
Good morning, everyone.
Hi, Dima.
Coming back to your projects, may I please ask you what's the added value of localization of roofs? Because it's quite curious, and just would like to hear from you.
Localization from the localization
right.
of the roof, yeah.
Right.
From a drone, from a flying drone, yes.
From drones. Yep.
So the added value. Okay.
Because I do not understand what's reason behind of localization of just using some AI technology.
Actually,
Alexander, I think Alexander, correct me if I'm wrong, but they're trying to achieve they're trying to create something like Google Map type of.
Yeah, actually, fortunately, I know a lot about this project, and this is just one slice of implement AI parts in this project, and roofs is just one type of objects that we are going to detect in the future. And I already explained this to students who are attenders of this course, but for you guys who just joined us, brief overview. This technology allows us not just only see the roofs and so, but perform analysis among different types of objects. For about roofs, it is important to know what type of buildings we have, whether those buildings are registered officially or not, so we can control building things and so on. In addition to that, we can build GIS systems, like we also call them GIS systems, that generally can be considered like mapping tools that are built automatically just by observing the area under the drone by camera. And it allows us to update the status of the landscape daily or even more often to control if anything is happening there, like maybe For example, for forest, if someone has stolen the tree from the forest, it's actually a kind of crime, and this can be automatically registered by drone without involving people. You should understand that people resource is the more expensive resource, and also the performance of drone, it can cover drone or satellite or aircraft. They can cover much bigger areas a day than people can do physically. So even natural disaster analytics can be based on such technology, because if we know the places of buildings, we can detect the damage degree of different parts of buildings, or maybe availability of this region throughout this road system if we had earthquake or something. If we can deal with fires for forests, many things can be analyzed in a way like this. Roofs is just one of entrance point how to develop the system for a wider set of types of objects. This is the answer.
Thank you very much. Thank you, Hiroshi. Thank you, Alexander. I heard that Greece government also, they're utilizing almost the same technology, just detecting pools in villas, and just to know who is not paying taxes for like specific taxes. And I think I see some parallels in these activities. Thank you.
Thank you.
May I ask one more question to
Yeah.
Hiroshi?
Please.
Hiroshi, how do you see the, let's say, difference in the how would say politics here in Japan regarding IT, regarding AI, let's say, usage and personal rights and so on, yeah, and especially, let's say, in comparison, for example, with China, yeah, because everybody talking that China now, let's say, is a leader, yeah, because they, let's say, don't protect too much personal rights, yeah, but that's why they have this boom, yeah, in data science, in AI, yeah. So how is it in the Japan, yeah? So in comparison with China, with Europe, yeah, where it's very strict.
I think Japan is like, I would say, not as strict as Europe, but not as bad as China. So like, basically, we have, like this privacy protection law, but like, as long as, I guess, the individual cannot be identified, you can use, this information for analysis. Whereas in China, as you probably know, that everything you do is actually identifiable. So like in the individual level. So this is like in the Western countries, or Japan, it's not allowed, because it's like a serious infringement of human right, I guess, privacy, and a lot of people wouldn't feel comfortable. I know that in some states in the U.S. as well, they illegalize it. I think Ukrainian AI company Ring Ukraine, as you probably know, they are having trouble, like in places like California. They cannot. They have to encrypt the facial data, so that people cannot be identified. So that kind of thing. So this is pretty similar in Japan as well. So and what you said is true. Like in China, this is why they can collect a massive amount of personal data, and they can use this for analysis. So this contributed to the advancement, the rapid advancement of their data science and AI technology. So this is kind of concern of everyone, because they are, in some areas, they're way ahead of other countries. But I would call it like a new Cold War even. But in Ukraine, yeah, so like I think it's the same as Russia as well. I'm not sure how things work in Ukraine, but I think in Ukraine, things are much closer to the West. People don't want to be, giving, privacy information to the government, or they don't want to be governed by authority. But the countries like Russia or China, they have a very little protection of the privacy, and yeah, this is why I think that they're a big threat, to other countries. But also like I have to admit that this, because to improve the model and pursue the accuracy of the model, you need as many data as possible. So you have to kind of take balance. But if you look at Japan, we are much closer to the West. People don't want to give private information, and there's a strict law against it, such as GDPR, like in Europe. So we have a similar law as well. So as most Ukrainians are, used to work, with European and North American companies, I believe that they can provide similar solution to Japan as well. But how, which country is going to win? I'm not sure about it. Like this is AI can be a huge weapon and a big threat to civilization, but I don't want the countries like autocratic countries like China or Russia taking over the world. So this is a big balance between like the privacy protection and the technological advancement. This is something that has to be solved in a political or diplomatic level, I think.
Okay, thank you.
So guys, if no questions, more. The Russian.
Yeah.
Thank you so much.
No problem.
We really appreciate your time and your effort and your presentation. Thank you very much. I hope this information was very important and interesting for our students. For me, at least, it is a very nice set of new facts and.
Yeah, it's a pleasure. Thanks for this opportunity, and I'm looking forward to having something similar. Hopefully next time in real life. And yeah, thank you for all you guys paying attention to my speech. Thank you very much.
Thank you.
So now I'm going to shut down. Thank you.
Bye, Chris.
Bye.
Thank you.
Bye. Bye. Bye.
Thank you. Arigato.
Arigato.